Okay, we're ready for lesson 4 of module 4. This lesson is called Solving a Linear Equation. So in the last lesson, we looked at linear equations and we talked about the definition, and we saw many examples of checking to see if a particular value for a variable was a solution to an equation. So in this lesson, we're going to talk about solving equations, and to solve an equation is simply to find all the numbers x that make the given equation true. So if I had an equation like 4x plus 1 equals 13, I could look at it and think about what x would need to be to make that equation true. In other words, to make the left side equal to 13. And I could see pretty readily that if x equals 3, 4 times 3 is 12, plus 1 is 13. That would be the solution to that equation. This one here, this equation down below, it's pretty hard to look at and figure out what number to put in for x to make the left side of that equation equal to the right side. So what we want to do in this lesson is to look at some properties that will help us do that. And so if we look at this equation right here, you can see that this equation is true. This is a true equation because the left side equals the right side. 4 plus 1 is 5, and 7 minus 2 is 5. So this is a true equation. And we're just going to talk about it. If I went and added 3 to both sides of this equation, I could ask myself, would that still be true? So this would be 8, and the other side would be 7 minus 2 is 5 plus 3 is 8. So it would still be true. Okay, what if we added 3 to one side and 2 to the other? Okay, if we do that, then we have 8 on this side, and we would have 7 minus 2 is 5 plus 2 is 7 on that side, and this is not a true equation. So by adding 3 to one side and adding 2 to another side, I end up with something that's now false, even though I started with something that was true. Okay, what if I multiplied both sides by 5? So I'd have 5 times 4 plus 1 over here, and I'd have 5 times 7 minus 2 over here. Okay, so this would be 5 times 5, or 25 on the left side, and 5 times 5, or 25 on the right side, which is still a true equation. Okay, what if I multiplied the left side by 10 and the right side by 3? That becomes, this is just a parentheses, that becomes 10 times 5, or 50 on the left side, and 3 times 5, or 15 on the right side. No longer a true equation. Okay, so we could go on, but by now I think you're getting the idea that if we do the same thing, if we start with a true equation and we do the same thing to both sides, we'll keep a true equation. If we don't do the same thing to both sides, as in this case, we will end up with a false equation. Okay, so that leads us to the properties of equality. So what these properties tell us is that if we start with an equation that is true, so in this case, A equals B. So if A equals B, then A plus C will equal B plus C, which is what we saw in the example just before this. The same thing's true for subtraction. So if A equals B, then A minus C will equal B minus C. For multiplication, if A equals B, then A times C will equal B times C. And if A equals B, then A over C, or A divided by C, will equal B divided by C, where C is not equal to 0, because you can't divide by 0. So those are the properties of equalities, and what those are going to do is help us solve difficult equations like the one we saw on the opening screen, the one that we couldn't do mentally. Okay, so let's look at this one. We want to solve this linear equation. In other words, we want to find a value for x that makes this equation true. So what we want to do is transform this equation into this format. We want it to be in the format of x equals some number. And when we do that, then we will know that that's the value for x that makes the equation true. Okay, so take a look at this one and think about what would be one of those properties of equality that we could use that would lead us to a solution to this equation. Okay, so we're going to start by assuming that there is a number x that will satisfy this linear equation, and start applying the properties of equality. So what I want to do is I want to make sure that I have all of the terms that have the x variable in them on one side of the equation. And so to do that, I have to either subtract 2x from the left or subtract 4x from the right. So I'm going to subtract 2x because it seems more straightforward to me. And I like to do something where because I like to keep the left and the right side separate. I'm going to draw a line down there and keep my equal signs lined up. So I'm going to have over here 2x, and I'm going to subtract 2x, and I'm already subtracting 3, and that's going to equal 4x minus 2x. Okay, so the part that was new is this part right here, subtracting 2x from both sides. So I used the second property of equality, so I know that this will still be a true equation that will have the same solution as that one. Okay, so now we can simplify here. And 2x minus 2x is 0x. And 4x minus 2x is the same as 4 minus 2 times x, or simply 2x. Okay, so what I have here, 0 times x is just 0. So we have negative 3 is equal to 2x. Okay, and so since our goal is to get the equation in the form of x, which is really 1x, what I need to do now is use the property of equality for division, and let's pick a color for that. So I want a coefficient of 1 on the x, so I'll divide by 2. So that gives me negative 3 over 2 is equal to 2 divided by 2 is 1, so this leaves me with x. So x equals negative 3/2. So I can leave it like that, or I could say my solution is x equals negative 3/2 is the solution to this equation. Okay, so one thing you want to do with all of these is to check your solution. So we use the properties of equality, and we said x is negative 3/2. So what I want to do now is what we did in lesson 3, which is to check and see if it's a solution. So I'm going to put that value for x in. So the left side of the equation, you can do this, you don't have to separate them out, but I'm going to. The left side of that equation would be 2x minus 3. X is negative 3/2, 2x minus 3, which is equal to 2 times negative 3/2 is negative 3 minus 3, which is negative 6. And the right side, is just 4x. So this would be 4 times negative 3/2, which would be, there's a 2, negative 2 times negative 3 would be negative 6. So the left side equals the right side when I put in that value for x. Therefore, that is the solution of that linear equation. Okay, here's another equation. So when you're doing these, remember that our goal is always to get the equation transformed into x equals some number. And that will, then we can immediately read what the solution is because it gives us the value for x. So we can use any of the properties of equality, but sometimes one thing is better than the other. So what we tend to want to do is to gather all of the terms that have x on one side of the equal sign and all of the constant terms on the other side of the equal sign. So how would we do that in this case? And I'm going to go ahead and draw my line here just to keep these separate. So the easiest thing to do right here, and it's not the only thing to do, but it will work, is to, we'll get this x term by itself if we add 21 to both sides. So I like to do it this way instead of rewriting the whole thing. So I add 21 to both sides, and that gives me 3/5 x is equal to, and now I need to add on this side. The negative 21 plus 21 was 0, so I don't need to show that. I could put it here for now, plus 0, just so you know I didn't ignore it. And then 15 plus 21 is 36. So 3/5 times x equals 36. So once again, we're going for that coefficient of 1 in front of the x. And in these equations that have fractions, and I do encourage you to leave them as fractions and not be working with decimals, because the numbers will work out more easily for you. So let's pick a different color so we can see this next step. What I want to multiply by to get a coefficient of 1 here is the reciprocal. So if I multiply by the reciprocal there on both sides of this equation, and remember I have to do it on both sides because that property of equality says if I want to keep this a true equation, that I need to use those properties of equality all the way down. Okay, so 5/3 times 3/5 is 1x. So on this side, I have x equals, and I have a common factor here that I can factor out. That would leave 12. 36 divided by 3 is 12. 12 times 5 is 60. So x equals 60 should be a solution to that equation. But again, I always want to check. So I'll let you look at that for a minute, and then we will go and we'll take this x equals 60 and put it in and see if it makes that a true equation. Okay. X equals 60. So the left side would be 3/5 times 60 minus 21, which is equal to 60 divided by 5 is 12. This would be 36 minus 21, which is equal to 15. And the right side is already 15, so I know that I have a solution to that equation. X equals 60 checks out. Okay, here's another equation, and this one's starting to look a lot more complicated, but it's still just a linear equation because notice we have an expression in x, a linear expression in x, set equal to another linear expression in x. So one of the things that we can do before we start using the properties of equality is to simplify the left side and the right side of this equation. So I can start with the left side here, and notice that there are two terms. There's a term and there's a term that have x in them. So I want to put those next to each other. 1/5 x plus 1x plus 13 is the left side of that equation. And okay, so I'm gonna work on this separately, and then we'll put it back together. So the left side becomes 1/5. So this is 1/5 plus 1 times x plus 13. So this is equal to, that 1 could be thought of as 5/5. So it's 6/5 x plus 13. Okay, so we'll keep that in mind. 6/5 x plus 13. Okay, so the right side of this equation is 1 minus 9x plus 22. So on this part, I can put that 22 and the 1 together to make it a little simpler looking. So this is 1 plus 22 plus, I'm going to call this plus a negative 9x. Okay, so this would be 23 either minus 9x or plus negative 9x. Okay, so now that we have transformed both sides of this equation, we can work with the simpler equation and use our properties of equality. So let's go ahead and rewrite this down here. We've got 6/5 x plus 13 is equal to 23 minus 9x. Okay, so I want to again get this in the form of x equals some number. So I want to get all the x terms on one side. So the way I see an easy way for doing that would be to add 9x to both sides of this equation, plus 9x. So on the right side, it's pretty simple. It's now just 23 over here. So because negative 9x plus 9x becomes 0x. This is really plus 0 times x, which is 0. Over on this side, I'm going to think of 9 as 9 over 1 equal to 45 fifths, because I need to add those coefficients. So this would be 45 fifths plus 6 fifths times x plus 13. So I use the distributive property there. So this gives me 51 fifths x plus 13 is equal to 23. Okay, I'm running out of room, so I'm going to just move this up here for you, so make sure you have your notes down. Okay, so starting over from here, and with the goal of getting x by itself, we're going to get this 13 off of the left side. So in order to do that, I want to subtract 13 from both sides of that equation and then rewrite what we have. So this would be 51 fifths x, and positive 13 minus 13 is 0, so I can leave that off, is equal to 23 minus 13, or 10. Okay, and then once again we have this coefficient on the x that we want to eliminate, so we'll multiply both sides by a number that makes that 1, so that's going to be 5 over 51. I have to do it to both sides, 5 over 51, and we can straighten out, simplify again. So this whole coefficient on x, this part right here, multiplies out to 1. So 5 is going to cancel, the 51's cancel. So this is 1x. So now I have x equals, and I have a number over here. 10 times 5 is 50 over 51. A good habit to get into with these is to always go back and check these solutions back up in the original equation. So that's what we're going to do now. So we got x is equal to 50 over 51 for that. So let's check the left side. 1/5 times 50 over 51 plus 13 plus 50 over 51 is equal to, here we can cancel out a factor of 5, so this would leave 10 up here. So this would be 60 over 51 plus 13. And we might need to find out what 13 is in 51st. Okay, so I did a little multiplication over here and saw that 13 times 51 is 663. So this is going to be 60 over 51 plus 663 over 51, which is going to be 723 over 51. Okay, so this side, the left side, became 723 over 51 when we evaluated that expression. So now let's check the right side. Okay, so I'm checking the right side now. So I've got 1 minus 9 times 50 over 51 plus 22. Okay, so I want to combine these, so I have 23 minus 450 51st. Okay, so now 23 times 51 is 1,173 over 51 minus 450 over 51, and that equals, okay, so 1,173 minus 450, I see over here on the side, is 723, right there. So what that tells us is that this is 723 over 51. So that's the right side, that's the left side. So my solution x equals 50 over 51 checks out to be a correct solution. Okay, now it's time for you to try some exercises. You have these in your book, and you can work on exercises 1 through 5 independently. Pause the video, come back and check your answers. And as always, if you want to do one equation at a time or one problem at a time, then that's a good way to do it too. Okay, so go ahead and work on number 1 and then come back and we will talk about it together. Okay, so for number 1 here, I want to take this linear equation and simplify it a little bit before I start solving it. And I wonder if you notice what this equation is. This is the equation that we translated in one of the earlier lessons, where we had, looks like we're adding odd or even consecutive numbers. So we've got x, here we've got x plus 2, x plus 4, and x plus 6. So those would be consecutive even or odd numbers. And we're saying that the sum of those adds up to negative 28. Okay, so what I started by doing was recognizing that I had 1x and 1x and 1x and 1x. So I put those together as 1 plus 1 plus 1 plus 1 times x, or 4 times x. So I have 4 x's, 4 times x, and then I can add my constants together. 2 plus 4 is 6, plus 6 is 12, so there's my 12 equals negative 28. So those properties that I used are the commutative and distributive. The distributive property is the one where I went 1 plus 1 plus 1 plus 1 equals 4 times x. And the commutative property said I could move these things around to be in a different location because everything's being added together. Okay, so I am supposed to solve this equation. So now I've transformed it. Now I'm going to start using the properties of equality. So I want to get x by itself. So subtracting 12 seems like a good idea here because it's going to get this x term all by itself. Okay, so let's draw my line down to keep the two halves separate. Now 12 minus 12 is 0, so this is plus 0. So I have 4x plus 0 is equal to negative 28 minus 12 is the same as negative 28 plus negative 12. So this is going to be negative 40. Okay, so I have 4x equals negative 40. So at this point, you may be able to see what the solution is, or you can take it one step further and divide to get that coefficient of 1. So divide by 4, which gives me 4x divided by 4 is just x. Negative 40 divided by 4 is negative 10. So x equals negative 10. And that was the division. Well, first we used the subtraction property of equality, and then we used the division property of equality. And x equals negative 10. Okay, so to check my solution is correct, I'm going to want to put negative 10 in for x up here in my original equation and check to see that the left and the right side are equal. So let's look at what that would look like. So I would have, I said x equals negative 10 is the solution. So putting that in to this equation here would give me negative 10 plus negative 10 plus 2 plus negative 10 plus 4 plus negative 10 again plus 6. Okay, so I like having these parentheses around the negative number just so I know that that negative sign goes with the number and it doesn't get lost. So I've got negative 40. I'm going to go ahead and group these again just like I did when I solved it. Negative 40 plus 12. I'm working on the left side of this equation right now. Negative 40 plus 12, which is equal to, I'm going to need to subtract these. My answer is going to be negative, and 40 minus 12 is 28, so negative 28. So the left side is negative 28, the right side is negative 28, so my solution checks out. All right, now we're going to look at number 2. So if you haven't already tried it, you should pause the video and give it a go, and then come back and check your work. Okay, so the first thing I want to do with this equation is to work with the left and the right side and to simplify it by using the distributive property. So my reason, or my, what does it say, the property that justifies my first step is going to be the distributive property. And the way I'm going to use that on the left side, so the left side of my equation, I'm going to rewrite as 2 times 3x plus 2 times 2, which is equal to 2 times 3 is 6x plus 4. So that's the left side of my equation. The right side, so that's just a simpler expression. So the right side is 2x minus 1 plus x. Well, I can reorder that by commutative, so maybe I should put distributive, commutative again. I've got 2x plus x minus 1, which is equal to 2 plus 1 times x minus 1, which is 3x minus 1. So that's my right side, 3x minus 1. My left side is 6x plus 4. So I'm going to rewrite this equation with those simplified expressions. So I have 6x plus 4 is equal to 3x minus 1. So now I'm going to start using the properties of equality to work to get this equation in the form of x equals some number. Okay, so first thing I want to do is get the x terms on one side. So I know that if I subtract the same thing from both sides, I will get an equivalent equation. It's going to have the same solution. It's going to still be true. So 6x minus 3x is the same as 6 minus 3 times x, which is simply 3x. And I still have plus 4 here. And then 3x minus 3x is 0 times x, or just 0. So this is 0 minus 1. So I've got 3x plus 4 is equal to 0 minus 1 is negative 1. Still working towards having x on one side and all of the constants on the other. So let's go ahead and subtract the 4 from both sides and rewrite. So 3x plus 4 minus 4 is just 3x. Negative 1 minus 4 is negative 5. And so I'm almost there because I have the x term on one side, everything else on the other, and now I can divide to make the coefficient of x 1. So we end up with x equals, I'm running out of room, negative 5/3 for my solution. X equals negative 5/3. All right, and as always, we want to check that back in the original equation. So here's what that would look like. Okay, so when I put in x equals negative 5/3 into my original equation, so here's my solution. I'm putting it in here. So I'm going to do the left side first. So 2 times the quantity 3 times negative 5/3 plus 2 is equal to all of this. You can study it. I get negative 6 for the left side. And then when I plug negative 5/3 in here, I get 2 times negative 5/3 minus 1, which I'm writing as 3/3, plus negative 5/3. And this all straightens out to negative 6. So the left side equals the right side. So x equals negative 5/3 is a solution to this equation. Okay, so I'm going to work on number 3 now. So again, if you haven't done it yet, pause the video and try it on your own. So for my first step, I'm going to gather the x terms on the right side of this equation. So to do that, I'm going to subtract x from both sides. I'll draw my line down just so I can keep my sides separate. So if I subtract x from the right-hand side, then I also have to, let me use a different color. I have to do it from the right as well. So we're going to subtract x and subtract x over here. Okay, so x minus x is 0x, because it's 1 minus 1 is 0. And I'm left with negative 9 on this side, equaling, so now I have to straighten this out. I want 3/5 minus 1x minus 1 times x on this side. But I could rewrite my 1 as 5/5. So I've got 3/5 minus 5/5 x. So what I'm going to end up with is negative 9 is equal to, well, 3 minus 5 is negative 2, and they're fifths, negative 2/5 x. I'm going to continue up here. Negative 9 is equal to negative 2/5 x. Okay, so here's another example where I want to multiply by something that will make the coefficient of my variable x equal to 1. So I want the reciprocal of this number so that I get 1x here instead of negative 2/5 x. Okay, so that's going to be this number right here, and I'm going to have to multiply on both sides by it. It will be negative 5/2. So I chose a negative because I want to have a positive 1 coefficient there. So let's straighten that out and see what it looks like. So this is multiplication here. So I'm going to have a negative times a negative is a positive. So I'm going to have 45/2 is equal to, now my negative 2/5 times negative 5/2 becomes positive 1. So this is just x equals 45/2. We always want to check our solution, but before we go on, I want to make sure that I was clear. The property that justified our first step was the subtraction property of equality and the distributive property that put these two things together. Okay, so let's check out our solution here. So to do so, I need some more room here. So we had x is equal to x was equal to 45 halves, or 45/2. So the left side of this equation would be 45/2 minus 9, which I want to write with a common denominator, so that would be 18/2. So 45 minus 18 is going to give us 27 halves. So the left side is 27/2. The right side, we still have to check out, that would be, the right side of this equation is 3/5 x, and so we'll put in our 45/2, and you can see you have a common factor here that we can factor out. That becomes 1, this becomes 9. So the right side, as we multiply it out, we'll get 3 times 9, or 27/2. So the right side is also 27/2, so it checks out. Okay, I'm going to work through exercise 4 for you. So once again, Pause the video if you haven't tried it on your own yet. Okay. Okay, so I use the addition property of equality because I'm working towards getting all the variables on one side of the equation, and this seemed the most straightforward way to do it. So I would be left with 29 minus 3x plus 3x, just gives me 0x there. So I have 29 is equal to 5x plus 3x, which is 5 plus 3 times x, or 8x, plus 5. Okay, now I want to move the 5 to leave the x term by itself. So the way we're going to do that is to subtract 5 from both sides. Straighten out, I get 20, let's be consistent and use blue. I get 24 is equal to 8x. And right now, we can kind of see the solution. Dividing both sides by 8, x is equal to 3. And putting x equals 3 into this equation up here, actually I can do that pretty simply. So I've got 29 minus 3 times 3, which is 29 minus 9, or 20, on the left side. And looking at this, okay, sorry, and then looking at the right-hand side, 5 times 3 is 15, plus 5 is 20. So by putting in x equals 3, I get 20 equals 20, and that checks out. Okay, let's look at number 5. Once again, if you haven't attempted the problem, you should do so now. Okay, so the first thing I want to do on this equation in number 5 is to get the x's all on one side. And since this side of the equation only has an x so far, I'm going to subtract 1/3. So I'm going to use the subtraction property of equality to start with. Okay, so let's write our equation. We've got 1/3 x minus 5 plus 171 is equal to x. So I'm going to start off by noting where my equal signs are going to lie. And then I'm going to subtract that 1/3 x from both sides, because I know that will keep minus 1/3 x. That will keep everything balanced. Okay, so 1/3 x minus 1/3 x is just 0x. So then I've got negative 5 plus 171. And on the other side of our equation, we have 1x minus 1/3 x. So it's 1 minus 1/3 times x. So this is going to be 2/3 x on the right side. And on the left side, we're going to have 166. 166 is equal to 2/3 x. So we need to multiply in order to get rid of that coefficient. You can think of it as multiplying or dividing but whatever it is needs to be done. Okay, so then the right side of our equation is x, because 2/3 times the 3/2 make 1. So I got 1x over there. Over here, I'm going to simplify this. So this looks like it could be 83. 83 divided, or 166 divided by 2 is 83. Okay, I've got to do this 3 times 83. Whoops. 3 times 3 is 9. 249. Okay, so if I want to say that x equals 249 is a solution, then I need to check it up in my original equation. And I get, checking out the left side, I get 1/3 times 249 minus 5 plus 171. So 1/3 of 249 is just 83 minus 5 plus 171 equals 249. And the right side was equal to 249 because it just had an x. So the left side and the right side are equal, so I did the problem correctly. My solution is correct. Okay, the lesson summary is on your problem set page. It just summarizes the properties of equality that we talked about, and that you can transform equations into simpler forms by using them. And so it says the properties, and then that you're always looking to get to transform your equation until you get the form x equal to a constant, and that will be the solution. So, okay, good luck with that. Good luck working with the fractions. This is a good chance to refresh and solidify your operations with fractions. So if you need help, don't be afraid to ask. And if you need help with the fraction addition, subtraction, the integers, subtracting negative numbers, whatever it is, Khan Academy is great for that. So see if you can maybe seek out some resources to help you in that area. Okay, good luck, and I'll see you back for lesson 5.